In this video, you will learn how to solve different rational equations. So let's recall that when we add or subtract fractions, we need to get the LCD, or the least common denominator, or the smallest number that can divide both the denominators. So that is similar to solving rational equations. Now let's try solving some problems here. Let's say we're given this problem here. 1/3 plus 4/5 equals x over 9, and then we have to solve for the value of x. Take note here that the fractions on the left have different denominators. So we can solve this first by finding the LCD of these two fractions. Now we'll look for the smallest number that can divide both 3 and 5, or you can just simply multiply 3 and 5, which is just equal to 15, and 15 will be our LCD, because 15 is divisible by both 3 and 5. So let's write 15 as our common denominator. And now let's solve this. So 15 divided by 3 is 5 times 1. So we just have to multiply the quotient of 15 and 3, which is 5, times 1. And then we copy the operator sign, which is plus. And then we do the same thing with the other fraction. So 15 divided by 5, that is 3. And we multiply by the numerator, which is 4, so that is times 4, equals x over 9. Then we simplify this one. So that would be 5 times 1, which is 5, plus 3 times 4 is 12, over 15 equals x over 9. Then we further simplify that. 5 plus 12, that is 17 over 15 equals x over 9. And now we solve for x. So how do we do this? We just cross multiply. Okay, so we multiply 7 and 9, so 17 and 9, so that is 17 times 9 equals x times 15, and this is just equal to 153 equals 15x. Now to finally solve for x, we divide both sides by 15. Okay, therefore x is equal to 153 over 15. We can further reduce 153 over 15 by dividing both the numerator and denominator by 3, since 153 and 15 are both divisible by 3. Okay, so the value for x is just 153 divided by 3, and that is 51, over 15 divided by 3, that is 5. So our answer is 51 over 5, or just 10 and 1/2. I meant not 1/2, 1/5. Okay, 10 and 1/5, because that is 5 times 10, which is 50, plus 1, which is just equal to 51 over 5. Now let's solve another problem. In this case is subtraction. So we're given here 2/3 minus 1/5 equals 7 over 3x. And we have to solve for the value of x. Now let's simplify this expression on the left first. So we get the LCD. Our denominators here are also 3 and 5. So we can just simply multiply them, 3 and 5, which is equal to 15. So this is the smallest number that can divide both 3 and 5. So that would be 15 divided by 3 is 5, times the numerator, this one, 2, and then copy the operator sign minus, and then we do the same thing here. 15 divided by 5 is 3 times 1 equals 7 over 3x. Then we simplify. 5 times 2 is 10 minus 3 over 15 equals 7 over 3x. And if further simplify that, 10 minus 3, that is just equal to 7 over 15 equals 7 over 3x. And now we can solve for the value of x. We can cross multiply this. Alright, so that would be 7 times 3x equals 7 times 15. So this is 21x equals 105, and then we divide both sides by 21. Therefore, x is just equal to 105 over 21. And 105 is divisible by 21, and that is just equal to 5. Therefore, the value of x is equal to 5. And by the way, you can solve every rational equation by multiplying both sides of the equation by the LCD of both sides. So in this case, you can multiply both sides by 3 times 5 times 3x, so you can just finally solve for the value of x. But in the method I showed you, I solved one side of the equation first before finally solving for x. So it will be up to you. How about if we're given this rational equation? So we have here 5 over x plus 2 minus 3 over x minus 2 equals 2x over 4 minus x squared. Notice here that the denominators are not only numbers, but they have variables. And not a monomial, but binomial. So the same method or process, we need to get the LCD. But take note here that we have a difference of 2 squares. So we need to split this or expand this or factor this so before finding the LCD. Now we can factor 4 minus x squared as 2 plus x times 2 minus x. And we can rewrite 2 minus x as negative of x minus 2. Therefore, we can just write this as negative x minus 2. And 2 plus x can also be written as x plus 2. They're just equal anyway. And now let's find the LCD of the whole equation. So notice here that the denominators of the equations on the left are x plus 2 and x minus 2. And the denominators of the equation or expression on the right are 2 plus x or x plus 2 and x minus 2. So they are just equivalent. So we can just simply multiply both sides of the equation by x plus 2 times x minus 2. So this would become 5 times x plus 2 times x minus 2 over x plus 2 minus 3 times x plus 2 times x minus 2 over x minus 2 equals 2x times x plus 2 times x minus 2 over negative x plus 2 times x minus 2. And now we can eliminate the common factors. So here the common factor is x plus 2. That would cancel out, and here is x minus 2, and here are x plus 2 and x minus 2. So we'll be left with 5 times x minus 2 minus 3 times x plus 2 equals negative 2x. Then we can expand this, so we can solve for the value of x. So let me delete this. So this would be 5 times x minus 2. We just distribute 5 to x minus 2. So we have 5x minus 10, and then we distribute 3 to x plus 2. So it would be negative 3x minus 6 equals negative 2x. And then we combine like terms. So 5x and negative 3x are alike. So 5x minus 3x is just equal to 2x. And then negative 10 and negative 6, that would be negative 16 equals negative 2x. Then we transpose negative 16 to the right, so it would become positive 16. So our equation would become 2x equals negative 2x plus 16. And then we also transpose negative 2x to the left. We transpose negative 2x here. This would become positive 2x plus 2x equals 16. And 2x plus 2x is 4x equals 16. And we divide both sides by 4. Okay, so our x would be equal to 16 over 4, or just simply equal to 4. So this is the solution to the given rational equation. Now let's solve another problem. So let's say we're given here 3 over x plus x over x plus 2 equals 4 over x squared plus 2x. So the denominators here on the left, we don't need to factor them because they are already in their simplified form. But the denominator here on the right, we need to simplify this or factor this. So we can write x squared plus 2x as x times x plus 2. So we factor out x. Now we can write or rewrite this equation as 3 over x plus x over x plus 2 equals 4 over x times x plus 2. And now we can find the LCD. Now notice that the denominators on the right are just the same or equal to the denominators on the left. So we can just simply multiply both sides of the equation by x times x plus 2. So this would become 3 times x plus 2 over x plus x, right there, x times x plus 2 over x plus 2 equals 4 times x plus 2 over x times x plus 2. Now we can cancel out the common factors. So here we have x, then x plus 2, and here x and x plus 2. So we'll be left with 3 times x plus 2 plus x times x equals 4. And now we can further simplify this. Okay, we distribute 3 to x plus 2. So this would become 3x plus 6 plus x times x is x squared equals 4. So we can arrange this equation based on the degree, or from the highest degree or the highest exponent. So that would be x squared plus 3x plus 6 equals 4. And then we transpose 4 to the left. That would become negative 4. So this would be x squared plus 3x plus 6 minus 4 equals 0. And this would become become x squared plus 3x plus 2 equals 0. Now we have a quadratic equation here. So let's solve for the value of x by factoring this. And by the way, if the quadratic equation isn't factorable, then you need to use the quadratic formula, which is just equal to x equals negative b plus minus square root of b squared minus 4ac over 2a. Now let's try factoring this quadratic equation, x squared plus 3x plus 2. So we'll look for factors of 2 that when we multiply them it would equal to positive 2, and then when we add them up it would equal to positive 3. So we only have 1 and 2. And now we can equate both of the factors to 0, or each of the factors to 0 to solve for the value of x. So this would be x plus 1 equals 0, where x is equal to negative 1. Then the other one is x plus 2 equals 0, where x is equal to negative 2. Okay, notice here that we have two values for x, which are negative 1 and negative 2. So to know whether negative 1 or negative 2 is a solution to the equation, we need to plug in each of the values of x to the original equation. If the value on the left is equal to the value on the right, then that means that value of x that you've solved will be the solution to the equation. So in this case, we plug in negative 1 and negative 2 to the original equation, which is 3 over x plus x over x plus 2 equals 4 over x squared plus 2x. If we plug in negative 1 here, okay, that would be negative 3, then negative 1, then 4, negative 1, 4, negative 1 squared, that is 1, minus 2. Alright. Okay, that would give us negative 4 for both equations, which are just equal, or both sides of the equation. Therefore, x equals negative 1 is a solution to this rational equation, whereas negative 2 is not a solution to the equation. Alright, so what if we're given this rational equation here? So notice that the denominators are not in their simplified form yet. So we need to simplify all of them. So this one, we need to factor this one, and this one. X squared minus 2x minus 3 can be factored as, okay, we look for factors of negative 3 that when we multiply them it would equal to negative 3. So that would be negative 3 plus 1, because the middle coefficient here, or the coefficient of the middle term, is negative. Therefore, the larger number should be negative. So that would be x minus 3 times x plus 1. And this one is the difference of two squares. We can write this as x minus 1 times x plus 1. And this one, x squared minus 4x plus 2, we can factor this as, okay, we look for factors of 2. Oh, sorry, this is supposed to be 3. Sorry. This should be 3. So we look for factors of 3 that when we multiply them it would equal to positive 3, and when we add them up it would equal to negative 4. So we can use negative 1 and negative 3. Now we have these simplified denominators. So we have x minus 3, x plus 1, and x minus 1. Now we can get the common denominator, or LCD. So we just have to multiply both sides of the equation by x minus 3 times x plus 1 times x minus 1. So if you're going to multiply this by x minus 3 times x plus 1 times x minus 1. This would become x times x minus 3 times x plus 1 times x minus 1 over x minus 3 times x plus 1 minus 1 over, no, 1 times x minus 3 x plus 1 times x minus 1 over x minus 1 times x plus 1 equals 2 times x minus 3 times x plus 1 times x minus 1 over x minus 1 times x minus 3. And now we can simplify this by canceling out the common factors. So common here is x minus 3 and x plus 1, and here x minus 1, x plus 1, x minus 1, x minus 3. Now we're left with 6 times x minus 1 minus 1 times x minus 3 equals 2 times x plus 1. And now we can simplify this. Alright, we distribute 6 here, so this would become 6x minus 6 minus x plus 3 equals 2x plus 2. Then we group like terms. 6x minus x is 5x. Then negative 6 plus 3 is negative 3. We have 2x plus 2. Then we transpose 2x here. This would become 5x minus 2x minus 3 equals 2. Then 5x minus 2x is just 3x. So 3x minus 3 equals 2. Then we transpose negative 3 to the right, so we become positive 3. So this is 3x equals 2 plus 3. So this is just 3x equals 5. And then we divide both sides by 3. This would give us a value of x that is equal to 5 over 3. So 5 over 3 is the solution to the given rational equation.